Hi everyone, I'm Dre, the host and founder of the Dragon Network, an online community where health IT professionals share experiences and discuss ideas with one another as they relate to healthcare technology. So I think today's video is going to be a little shorter than some of the rest of them. And that's because I just wanted to quickly touch on something that I've been learning a little bit more about lately, and I wanted to share some of the information sort of as I learn about it. So the topic is machine learning, and what I've been researching is how do these machines actually learn? So what are the learning mechanisms that allows a computer system to grow quote unquote smarter over time? So before we jump into how the machines actually learn, we'll just look really quickly at what machine learning is overall. So the concept was developed in the 1950s, and it was really part of some efforts to move towards artificial intelligence. The term itself was coined by an individual by the name of Arthur Samuel, who worked for IBM, and he had been trying to really look into implementing statistical and algorithm-based programming models into computer systems so that they could learn over time. His first sort of real attempt that was public was a checkers playing program that he actually debuted as part of the IBM 701 platform in 1956, I believe. And the term machine learning itself came forward in 1959. So I've been looking a little bit more into the technology behind machine learning and what it really means. I'm also going to do the same for artificial intelligence, so you'll likely see a couple videos from me in the future on that. But for right now, the piece that I wanted to share real quick is what the learning mechanisms are, or what the learning types are. So there's three main learning types that I came across. Those are supervised learning, unsupervised learning, and reinforcement learning. So we'll touch on supervised learning first. So the big thing behind supervised learning is that the data that's being considered is all labeled data, and the outcome that the machine is attempting to reach is something that is defined. So there's labeled data with a defined outcome. As data comes into the platform where machine learning's been programmed in this method, it's going to take a look at the data and it's going to place it where the algorithm says to place it, and then it's going to execute the logic that really looks at the outcome. So from a healthcare perspective, a good example of this one would be predicting the likelihood of the onset of type 2 diabetes, and it would take into consideration things such as the patient's height, weight, gender, age, smoking status, perhaps family history, and all those pieces of labeled data would then be placed against the algorithm, and a prediction or a percentage likelihood would be returned based on information that was already set out and defined within the algorithm. So that is an example of supervised learning. So the next one that we have is called unsupervised learning, and unsupervised learning differs from its supervised counterpart in that the data is not labeled. So data can be in any format, and it can be for any of these with machine learning. So it can be textual data, numerical data, image type data, user action type data like clicks, things like that. But in this case, the data isn't explicitly labeled, and we don't have a very clear defined outcome that's been programmed. So the machine is going to use the logic that it's been given to categorize the data into groupings. And then it's going to flag things that don't fit into the regular groupings. So it's going to put like together with like and flag anything that's not like. So the best example I can think of this actually isn't a healthcare one. I'll give you a healthcare one in a second. It's the photo app that is on my Mac OS operating system. So as I've uploaded, thousands and thousands of photos to the photo app, it actually will come forward and it will group people who look the same together. And first it's going to ask me who this is. So I'm going to click on it. I'm going to enter a name. Let's just say I've entered it as my sister. And then over time, it's going to continue to categorize new images that come in, and it's going to group them together based on their likeliness to that original grouping or category. So it's going to learn over time. It's going to get better and better identifying who belongs in a group. And then I'm going to confirm, oh yes, this is also my sister, or no, this is not my sister. That's the best example I can think, or the most simplistic example I can think of that most of you may have come across. In a healthcare environment, we can also see applications like this looking at population health type data where it's grouping things together. One of the examples that I was looking through as I was doing my research was a learning program that was looking for subsets of a population who had symptoms or signs of early onset dementia. So it was grouping them together. Again, it was using categorical information, so it was placing age-related people together. It was placing some of their symptoms together, and it was flagging things that looked like they belonged in groups that could predict onset dementia. So that's unsupervised learning. So the third and final type that I came across when I was looking at how these machines actually learn and what these programs are set to do is a concept called reinforcement learning. So that is when the algorithms or the setup is actually looking for a trial and error type system. So the machine is going to attempt logic, and then there's either a confirmation or a denial of what that logic is. These software programs just are going to continue with their trial and error approach, and then there's interaction from users or validation of the algorithms and the statistical models that will let it know over time sort of what the most optimal path is and what the quickest way to get from point A to point P is going to be using this trial and error approach. So how do they get through the data to the end goal with the minimum number of errors? So a good real-world example of this would be the machine learning logic that exists within self-driving cars. As things are going through the trial and error period, at first through the simulation models, there's going to be confirmation of yes, this is, no, this isn't. Over time, that gets to be much more refined, and the system gets better at identifying the correct path. So from a healthcare perspective, a great example of these reinforcement type algorithms are dynamic treatment regimes, so DTRs, and that is where you're going to take large volumes of data. You're going to have a program that will over time identify the likelihood of an outcome or the likelihood of a positive response for a particular treatment path. And it's going to consider, X times out of 10, this worked and this didn't. 4 times out of 10, this worked and that didn't. And it's actually going to start honing those over time so that when data elements are put forward, it's going to understand what the most appropriate and the most efficient and the best outcome path is going to be for the particular example or patient that it's looking at. So this type of DTR application of machine learning is something that's really exciting, and a lot of people are looking towards implementing things like this in precision medicine type spaces, in some of the more complex diagnostic spaces. One of the things that the machine can take into account, especially if it's looking at a large data set or a large data pool, is it can actually factor in the likelihood of outcomes for things that have delayed responses. So if it's considering data over a long period of time or a wide subset of patients, it can actually start to get better at predicting the longer term outcomes for things based on actions that are taken now. So that's really all I wanted to touch on for this week's video. So as always, if you like the types of videos that I've been posting, then go ahead and subscribe to the channel and hit your notifications so that you know when the next one will be posted. And if you're interested in joining the network or checking us out to see what it's all about, we do have a free trial period, and you can find details at network.dragon.com.